This is problem number 15 from section 10.4 in the book. This problem involves a quadrilateral that's inscribed in a circle, and we can use the information given in this problem about the circle to solve for the variables a and b. Before we get started, I want to look at a theorem from the books, Theorem 10.7 as it's named there, and it's a theorem that involves inscribed angles, and it relates the measure of the angle to the measure of the intercepted arc, which is the part of the arc that's inside of an angle. This angle here is an inscribed angle because the vertex is on the circle. We can relate alpha and theta in this problem here, alpha being the measure of the inscribed angle and theta being the measure of the intercepted arc by this relation, and that is that the inscribed angle is half of the intercepted arc. So going back to the problem, we know a lot of information here, and thinking about Theorem 10.7, if we want to solve for A, we want to look at that angle right there. That is an inscribed angle because the vertex is on the circle. So this arc right here would be our intercepted arc. Now there is an unknown piece to that arc, so we need to find the value of that, and we can use the fact that all of the arcs in a circle add up to 360 to solve for what I call beta in this problem. Once we know beta, then we can figure out what the measure of that intercepted arc is by adding 54 plus beta, and then we can set up this equation 3a is half of 54 plus beta, which is the intercepted arc. Solving for b would be a very similar process, except that our intercepted arc now would be the part of the circle inside of this angle, which would be that arc.